In this video, I'm going to show you how to take this part and turn it into a shell. So we're going to start with the shell button. Actually, not start with the shell button, but we're going to do the shell function. I'm going to start by selecting the surface that I want the shell to have an open face on. When I do that, I'm going to see, if I click the preview button, how the shell is going to turn out. I'm going to tell it that I want it, and bang, that's it. That's all there is to making a shell. It's pretty simple. If you don't start with the face, you end up with a hollow part without an opening. So we want to start by selecting the face that we want to be open, then hitting the shell button, and then working with the menu that's on the left-hand side to get the shelled part. So now what we want to do is we want to think about how the order of operations might matter here. And so what I'm doing now is I'm saying, let's take these unfilleted surfaces, which were this way because we had thought about machining the part. Now we're thinking about injection molding the part. So let me go in there to these lines, choose them, and create a fillet in there, a 1mm fillet, which would be more appropriate. And then you look on the inside of this shell and you see that those fillets don't really appear on the inside. And this is worrying me a little bit because I'm feeling like what's going to happen here is the part is going to be thicker in some of those regions where I've just added the fillet, just added material. So I'm going to use the evaluate functions in SolidWorks, and there's a lot of options, but there's one in here for thickness analysis. I'm going to choose thickness analysis, and as I choose that thickness analysis, I've got a couple of options that I can deal with here. I can look for the thin regions or the thick regions. In this case, I'm going to look for the thick regions, saying that my kind of maximum allowable thickness, or the maximum thickness I want in the evaluation, to be 2. And so here I am looking, and I'm seeing that most of my thickness is happening right where that radius happened. So my suspicions were kind of true. And it turns out if you hover over the model, it'll tell you what the thickness is wherever your mouse is hovering. So this means that we need to try to change the order of our operations. We kind of need that fillet to be there before we do the shelling. And so what you can do is simply reorder them in the design tree. And if your model's kind of robust and the operations are simple enough, you'll be able to reorder them. And here, although it's really dark on the inside, I'm not entirely sure why that's the case, you can see that now the inside is shelled and shelled with that fillet in there. So if we were to go back now and do the analysis again, or excuse me, the evaluation again, and do the thickness analysis, we're going to find a much better situation here. Of course, if we're thinking about injection molding a part, which we would when we're using this shell function like this, we really want constant wall thickness everywhere. And now we can see that we're down in the 1mm, very close to the 1mm range, which is the thickness we know that we have everywhere else. So there we are. We had the shell, we added a function, we added a fillet to it, caused a little bit of trouble, and went back and tried to fix that by reordering the way we did the operations.